Hey, 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 good evening, popular astronomers. And as you can see, we are on air. Good evening, and how are you? My name is Vicky, and this is Pop Astro Live. If you are a connoisseur of Pop Astro Live, you will know all about it. If not, here is what you are in store for. It is 1 hour of cutting-edge astronomy chit-chat. We have got 3 top experts to join us this evening, who I will be revealing in a moment. But most of all, this is your show. So because we are the Society for Popular Astronomy, we love you to participate and to join in. This is the only live astronomy chat show in the known universe. So what we love you to do is to comment away, get involved in the chat room. It's very busy. It's very active. Start commenting now. We'll start displaying your comments on the screen here. It's very nifty indeed. Does this thing get hot? I'm holding it like, let me have a, someone's just put this in my hand seconds before we went on. It's like a halogen electric cooker. It's made of halogen. No, it's not hot. It's not hot. It's not hot. So, okay. Tonight, then, we have got Dr. Tom Stallard, Associate Professor of Planetary Astronomy. We are going to Triton tonight. That is the moon I know a nout about. So the mission is a proposed mission called Trident, and it is currently in the discovery phase, up against 3 other missions, with funding going to 1 or 2 missions. We've also got Alice Shepherd, or as I like to call her, Alice Shepherd Moon. She is a citizen science officer at the Society for Popular Astronomy. She is going to be talking about that little frosty ball in the sky, Enceladus. It's the 6th largest moon of Saturn. Try saying that with after a couple of sherries. And so Enceladus is the 6th largest moon of Saturn, and after Titan, one of the most studied worlds in the system. It was discovered in 1789 by William Herschel and named after the Greek mythological giant Enceladus. And then we've also got Ophelia Wibisono. She is going to be here talking about the SMILE mission. More about that coming in a moment. So let's see, we have got the comments already coming in. Can I put this thing down? Video is a bit dodgy tonight. Oh, yeah, what's happened? So I'm in a new location tonight, which has supposedly got really decent internet. Ian, tell us what is the problem with the video, and we'll try to do a little bit of troubleshooting. Is it pixelated? Is it slow? I think Terry is running to tell the girls to switch off Netflix. So I'm in a new location tonight. I'm not on Anglesey anymore. And I will reveal where I am shortly. But if you just troubleshoot and tell us what the problem is with the internet. I am in almost like a proper studio here that's meant to have the most amazing internet. So I've got a new webcam. Could it be that? Pixelated and jerky? No. So the Taylor Swift documentary has been paused on Netflix. Let me try fiddling and fiddly-diddly-diddling with some of my settings. The captions are fine. Okay, so let's have a little look here. We're going to do a bit of troubleshooting. Oh, right. I'm going to maybe switch off the webcam. Let's have a look at my camera settings. High resolution, standard definition. Just completely disappeared. Tell me graphics are fine, but the video of me is poor. Pixelated and slight loss of sound, but I'm in an urban environment with amazing internet all around me. How can this be? How is this? I've reduced the resolution on the camera. That's troubleshoot 1. SD is much better. What does that mean, SD? How's this? Am I still pixelated and jerky? Right, I'm going to unplug the webcam, maybe. Right, okay. That's much better. Somebody said it's better now. Taylor Swift is paused. The girls in there are playing Monopoly with a Taylor Swift. Better now. There we go. Taylor Swift was draining all our bandwidth, Terry. It was her all along. Excellent, excellent. Okay, so hopefully this is going to be good. Let me know how the sound is. And okay, so first of all, it's traditional around about this time of night that I reveal my T-shirt. So would you like to know what is on the t-shirt. So this arrived in the post the other day. I've asked for a very special t-shirt. I've eaten 5 pieces of garlic bread, a bowl of spaghetti bolognese, and 2 helpings of Waitrose chocolate cake with 4 helpings of ice cream. So I'm really full and it's hurting to stand up. But the latest t-shirt is, check it out, retro SPA fans. It is Astronomy is Looking Up. It's one of our old t-shirts, which I actually saw a picture of Heather Cooper wearing. This is one of our finest new SPA t-shirts, and it's also very old at the same time, and it is a girl cut as well, so it's cinched in at the waist and it looks really great. And I even wore it to move house in as well, so that's how good it is. It's good enough to move house in. It's a great t-shirt, and that is available at popastro.com in our shop. But loads of brilliant t-shirts and mugs. Get kitted up with SPA merch because it's wicked. It's really great. So let's see what the comments are. Really good now. Robin said it's good now. We fixed it. That's great. The boss says it's good, Terry. The boss says it's good. Good now. Excellent. Excellent. Looking and sounding great. Hello, Sandra. How are you this evening? Great to hear from you as per usual. You have changed your avatar. That is really good. I'm assuming that is all the worlds of this. Check out Sandra's Facebook logo. Popular astronomers. It's got Mercury, Venus, Earth, Mars, Sandra's favorite planet, Jupiter, bit of Saturn there, bit of Neptune with a scooter cloud and a bit of Uranus at the bottom. So that is great. An old idea, but reimagined by the brilliant Joe Cummings. Very, very good. Very good. Okay, so now we are going to go across to Alice Shepherd. I've only ever spoke to her once before, but we have known each other on Facebook for absolutely ages. Got to remember how this works now, because I missed last week and I've forgotten what all the buttons do. Alice, I'm coming to you in 3, 2, 1. Here she is. Hi, Alice.
Hey, well done on sorting the technology.
Oh, we had to press pause on Netflix. It was as simple as that. There we go. But at least I knew what it was, though. At least I'd clocked the girls watching the Taylor Swift Netflix documentary beforehand. So, Alice, how are you and where are you tonight?
Oh, I'm okay, thanks. I'm feeling a bit sleepy, which is regular for me. I'm just south of London. Oh, don't tempt me. Yeah, it's been absolutely horrible weather. 0 chances of any stars tonight. But hey, I've got some pretty starry pictures.
I'm just trying to work out what they are.
This one is Particle Trails. It was made by a friend who does amazing paintings, and there is the aurora.
Very good, very good.
Yeah.
I'm not in my usual location, so I've had to ask the residents of the place where I'm broadcasting from, have you got anything spacey? Right, well, that's Gemini Jones. You all know who that is. Do you know who this is? This is the best that they could come up with for me.
What's the space connection? There's got to be one.
It's a space raccoon. It's what's it called? Rocket raccoon. It's a Marvel raccoon. It goes to space, apparently. I don't watch Marvel films, so I don't know.
Neither do I. He's awesome anyway.
Could anybody fill us in with who he is? It's Rocket Raccoon. He's a Marvel character. And this is, of course, Gemini Jones, sent to me by Paul Sutherland. So there we go. So, Alex, put them over there. Put them over there. Great, Alice. So thank you so much for agreeing to come on the show at relatively short notice. What are you going to talk about tonight?
Oh, we're starting off by catching up on my latest SPA column. Robin, I got your email. It will be on its way. It's just a bit of a nightmare week with spreadsheets.
Yeah,
I'm sorry. I always need chasing up with my articles. I've been writing them for a really long time. So my last one was on a bit of a problem that exists in citizen science sometimes, that when a project's over, it's over. And that can be really sad for the participants. And also for people who want to do another citizen science project, like, okay, we got all these amazing people together, we got all this brilliant data from them. Oh dear, we've lost them all. They've all finished 6 months ago. What on earth do we do now? How do we get them all back again? And a good way to get them back again is just to have a sort of wider platform like the Zooniverse or SciStarter. And even NASA has taken it up. So I noticed that NASA are doing various citizen science projects, or just linking to them, linking to other people's citizen science projects. They've got their own platform, and they divide it into things like Earth, solar system, galaxy, universe. So I told readers that I think it would be great to go and have a look at that. This month, you're going to get some very gadgety stuff on which I don't know very much about. So you're going to have to test it all for me and tell me for the next article whether it was good or not.
Oh, very good. Yes, I've read your column about the way that you can suddenly, you can be immersed in an amazing project and then it ends. And what was it? You put something about you had to bite your tongue saying that science isn't there to please you or something like that.
Oh, yeah. I'd forgotten that. Yeah, sadly. It does what it does.
Yeah, it does what it does. It does what it does.
It's like Pluto. No matter whether we call it a blooming planet or not, it does its own thing.
It don't care, and that's why I refuse to get drawn into the debate. Pluto don't care. Let it carry on with just being amazing and wild.
Yeah, it's amazing. That's the main thing.
Very, very good. So
how many people have switched off since we said we don't care?
We're just firmly in the center of the Venn diagram that says don't care. So, Alice, tell us a little bit more about Enceladus then, the little icy ball, the 6th largest of Saturn's moons.
Oh, yeah, Enceladus.
It's
cool. My favorite. It is my favorite moon in the solar system. Yes, in the dim and distant past, it was a master's in astrophysics dissertation for me. Yeah, I did a master's in astrophysics many years ago, starting in 2011, and I failed it in the end because my only real astronomy training is citizen science.
Okay.
Citizen science is the best science teacher in the universe, but what it doesn't teach you is how to pass exams or how to do the maths or how to do lots of calculus. I never learned that from Galaxy Zoo. It was not their obligation to teach me. There was no way they could teach me. So yeah, I did not get through that degree, but I had a great time researching Enceladus. It's a lovely, lovely little moon. It's so small. If you put it next to the UK, then its diameter would actually be smaller than Cornwall to Scotland. It's that tiny.
It's dinky little thing then.
Yeah, very, very dinky. Like and lots of the
white. It looks like a cue ball, a snooker ball, really, doesn't it?
It's so shiny, and why it's shiny is amazing, actually.
Yep.
Yeah. So something that tiny should not really be active. It shouldn't be doing anything, but it's doing a lot. The reason it's shiny is it's covered with smooth, brilliant ice from a sort of rain that has fallen down all over it. The source of that rain is Enceladus itself. It has what we call cryovolcanism. It's just the same as volcanism, but not with rock, it's with ice and water. It's throwing out all this water ice all by itself.
Well, how's it so active when it's so titchy?
That was the subject of my dissertation. My eventual conclusion is, I really don't know. I took a look at all the scientific literature on many different mechanisms, and none of them really seem to be enough, if you know what I mean. So the first thing I looked at was radioactivity. The Earth's core is full of radioactivity. It's just these things are about when a solar system gets made. Some of it ends up in the core. Then, of course, because it's really heavy, it stays in the middle. So all the heat is sort of left in there, and it's sort of blanketed by the moon or planet's crust. But, well, it seemed that any radioactivity obviously is going to decay. It's going to run out. So, no, that couldn't explain it.
Wow.
That perhaps it had shrunk over time. There was no evidence for that. The most popular and most likely theory is tidal heating. So I've spent part of today trying to illustrate something called resonance, which moons of Saturn and Jupiter do. Essentially, think of them going around in circles, and they all do it at the sort of speed which sort of fits to where they are. Like the closer into the planet, the faster they go. Lots of them are placed so that one going round twice, another goes round just once, or one goes round once, one goes twice, one goes 4 times. So they'll keep meeting in the same place. So I tried to make my fingers do this motion, have one doing one circle and another doing another circle at twice the speed. No, I can't do it. I was never good at PE. You'll just have to picture it or look it up on a diagram. But anyway, Enceladus is like that. 1 going round twice, 1 going round once, 1 goes 4 times. So they'll keep meeting in the same place. So I tried to make my fingers do this motion, have one doing one circle and another doing another circle at twice the speed. No, I can't do it. I was never good at PE. You'll just have to picture it or look it up on a diagram. But anyway, Enceladus is like that. there are various other moons of Saturn which go round and they keep meeting in the same places. That means their gravity tugs on each other. So their orbits are not circular, but they're sort of elliptical, they're stretched out. This means that as they sort of turn around on their orbits, different parts of them get pulled by Saturn's gravity at different amounts at different times. And the more elliptical the orbit, the more extreme this is. And of course, the gravity of the other moons. This keeps heating them up. It keeps sort of squashing them. If you squash a rock enough, or ice or anything, it's going to heat up. And it seems, well, the mathematicians did the maths, and it's not really enough to cause all that water on Enceladus to melt and be thrown out into space, but it still seems to be happening. So whatever the explanation is, and it may be a combination of factors, Enceladus is doing that. That means it's got warm liquid water protected by a shell of ice. Cassini flew through the plume. It found not just water, but it found molecular hydrogen and carbon dioxide. And you know what? This is amazing, Vicky.
Yeah.
The oldest life on Earth that you find around deep sea vents, that uses molecular hydrogen and carbon dioxide for something called methanogenesis. It's a sort of chemical use of food. It's not even photosynthesis. It's not like our own metabolism, but it works. It makes energy. So Enceladus might have the ingredients to support life, a bit like deep sea vent life.
Wow, yeah. That's pretty impressive. So any plans to go back there?
Not that I know of. From my dissertation supervisor, Carl Murray, he's brilliant, by the way. You should interview him. He was so sad, as they all were, when the mission ended.
Cassini.
But yeah, at the moment, I don't know if there are plans to go back there, but astrobiologists just love the place, and Europa as well. Europa is a little bit similar. That's one of the Jupiter moons, so I hope that's going to be studied in great detail.
Oh, wow. Yes. So fingers crossed there might be some weird hydrothermal vent dwelling weird things down there.
Yeah. Yep.
So the way you've described Enceladus is like, you know, when you get that amazing snow only about once every 10 years nowadays, when you go outside and it's just perfect and pristine and white and it makes you go, wow. Is it like that? This Slade planet, because it's Christmas every day on Enceladus.
I don't know. I always think of it as being like Enceladus taking a shower, and all the moons that are near it are all not quite as white and sparkly, but nearly, because all this matter is falling on them as well. In fact, it's Saturn's E-ring. One of Saturn's rings is Enceladus's fountain water.
Wow. Yes. So wow. So explain what the E-ring is then. Can we see it from here, with ground-based telescopes?
Probably not from any telescope I've got mind, but yeah. Gosh, don't ask me telescope questions. I'm absolutely useless. But anyway, yes, Saturn's E-ring. Most rings are made of sort of sand, rock, spit of ice. The E-ring is mostly ice, really tiny ice particles. And it does seem that Enceladus is the source of that ring. It's inherently unstable, so it's continually being replenished. Enceladus is kind of right in the middle of it. And it's also at the ring's narrowest and densest point, which does suggest that it's shooting the water into it. The water does sort of spread out bit by bit over time. And of course, other moons come into that ring, and then they get all this shower of water as well. So they get to take a shower because it's beyond the snow line.
It's keeping everybody. Yeah, it's the solar system's little shower going around and polishing all the other moons. Now, so you mentioned it was your favorite moon, and what tends to happen when people say that is I just copy them because I like it too now, and I didn't really know very much about it, but I'll always remember it now. That's such a fun sounding little place. One of the more innocent little moons of the solar system, maybe.
Yeah, I never thought of moons as innocent or not. We need to write a story about this.
It doesn't sound extremely hellish there. It's like probably where I would want to go for a holiday most.
Bit of ice skating.
Yes, absolutely. Oh, dangerous. Don't do it. Don't do it. Ice skating is a nightmare. Alice, there's just no clear skies lined up. The weather is grim, isn't it? I got a new telescope in spring. Ooh. And I've not used it since spring, give or take 1 or 2 nights. Did you see any Perseus? Did you see any Perseids?
We were able to sit out in our back garden a couple of times. I mean, obviously, we've got horrific light pollution in South London, but I think we saw a couple. We saw a couple of bright things. It was impossible to tell, but you can see stars a bit, and we thought we saw a few fast-moving things, one or two.
Oh, lovely, lovely.
So we're sort of, in fact, you know what, Vicky? We're sort of like the moons around Enceladus, because the Earth is plunging into the tail of a comet. So there's lots of water ice, lots of sand, that kind of thing. So you can imagine it being a little tiny bit like Saturn's E-ring. And we're sort of walking into it. And those meteors that we see, they're tiny bits of that comet tail. So yeah, there's lots of tiny, tiny things in the solar system. Of course, we're not getting coated in the thing.
Okay, Alice, thank you so much for your expertise. It's always wonderful to see you. Robin says here that everyone, Alice says her article for Popular Astronomy is on the way to me. RS, that means Robin's schedule, doesn't it?
Yeah. Sorry, Robin.
Alice, I'm a writer, and you would not be a writer unless you had editors sending you emails asking where the article was.
I'm afraid I've never changed. I was like that at school.
Yeah, last minute thrills, eh? Yeah. We're the deadline girls. We're the deadline girls. Bang on deadline girls. Alice, it's been an absolute pleasure, and I'm sure we'll have you back on again soon. Awesome. Now my next guest has disappeared. She was having connection problems. Might have to get Robin to come on and do a turn. Alice, it's been a pleasure, and I'll see you later.
Yeah, you too, Vicky. Bye-bye.
Bye. Bye. Woohoo. Okay. So, Robin, we might need you on in a minute. Ophelia isn't able to connect. She has disappeared and dropped out of the feed several times. And I did actually want to have a chat with you, Robin, because we can chat about, I heard the little noise. That might mean that she's back. Let's grab her now. Quick, Ophelia, I'm going to get you on now.
Hiya.
Hopefully you're not going to disappear again.
Yeah, me too.
Hey, it's very good to see you again. I was going to chat for a little bit before getting you on, but you kept on dropping away. So we're going to get you on right now. Are you trying to outshirt me?
I wore it especially for you because I know you like space shirts. So.
This is like it's like we've been pegged out on a washing line. So what? Oh, Robin. There we go. I see Robin's joined the feed as well. We might get him on in a little bit if you disappear. So what's on your shirt there, Ophelia?
I think they're just generic planets.
Generic planets, yeah.
Saturn-like.
Yeah.
There's a flying saucer there.
It's good enough for me. It's good enough for me. Now, you were on a couple of weeks ago. Remind us what you were talking about. Hang on. It was the aurora of Jupiter.
That's right. Yeah.
Yes, I remember. How good was that? So what have you been up to recently then? What area have you been delving into?
Still Jupiter's aurora. So yeah, my PhD is it will be on Jupiter's aurora until I finish.
Okay.
But today I thought I'd talk about.
Sorry, yeah, carry on, yeah. Far away. So what have you been up to today then?
Today, I'm just preparing for a big conference that I'm going to soon. So just preparing my talk for that.
And we are tonight going to talk about
SMILE.
Now, you gave me a choice of missions to chat about, and I realised I hadn't actually heard of SMILE. I'd heard of the other ones that you mentioned, and I thought, well, there we go. What's it about? So, what does SMILE stand for? Can you remember?
Not on top of my head, but I wrote it down. So, SMILE stands for Solar Wind Magnetosphere Ionosphere Link Explorer.
That's a pretty cool sounding mission.
Yeah. So it's going to do exactly what its name says. It's going to study the connection between the solar wind and the Earth's magnetosphere. I spoke about the solar winds briefly last time, I think. So it's this constant stream of charged particles or plasma released by the sun. When it gets close to the Earth, the particles from the solar wind gets stopped by the Earth's magnetic field. And this sort of magnetic protective bubble around the Earth is what we call the Earth's magnetosphere. And of course, other planets have magnetospheres like Jupiter. But what's really cool about SMILE is that it's gonna have a global look at the Earth's magnetosphere. So no other missions have done that before. all of our current fleet of space pass mission can only take very localized measurements, so we can only study what's going on in immediate surroundings. But SMILE can look at pretty much the whole day side of the Earth's magnetosphere, which is really cool.
So what kind of implications will this research have for us then?
Yeah, so you might have heard of something called space weather. It's how the environment sort of around the Earth is affected by the sun's radiation, magnetic field, and all of these, material that the sun sends out our way. And when the sun releases, a coronal mass ejection, that can disturb the Earth's magnetic field. It can cause what's called a geomagnetic storm. And that can be very hazardous for astronauts. Increased radiation that can kill off satellites if it's a really big CME. It can cause power outages here on the Earth as well. So the more we understand about what the solar wind is doing and how the Earth's magnetic field and magnetosphere respond to that, the better we can prepare ourselves for if one of these storms is coming our way.
So this is, from what I can make out here, quite an unusual partnership between the European Space Agency, ESA, and the Chinese Academy of Sciences.
Yeah. So I think there's only been one other mission where ESA has worked with the Chinese Academy of Sciences, and they were very sort of keen to build on that relationship.
That's cool. That's absolutely cool. So when it's due for launch, how is this thing has it been built yet? It's due for launch in 2023.
No, it hasn't been built yet. And part of it is actually built in my laboratory, and other sort of places in the UK, in Canada as well, and of course China. They're still being built, and I think the engineers they were very genius, because of course we had the lockdown, so they couldn't go into the lab to build the instruments. So they're really working very hard to make sure they meet this 2023 launch date.
Right. Okay. So the orbit is going to be quite unusual. How many times is it going to have to go around to get into that? So it's like not a slingshot orbit, but it's going to be highly inclined elliptical. It's going to be a long way out as well. Yeah. 120,000 kilometers. Yeah.
So at its furthest point from the Earth, it will be, about a third of the way to the moon.
So wow. Far. Yeah. Long way from
and it needs to do that, because that's the only way we can see a large part of the Earth's magnetosphere, and also the Earth's northern aurora as well. Of course, if you're too close, then you can only see a small part of the magnetosphere.
Excellent. So this is going to be an absolutely cool mission. It's the SMILE mission, due for launch in 2023. Now, you said that you had a meeting with, I had to Google what this meant and couldn't find the answer. The European PI. Who's the PI? What does that stand for?
So PI stands for Principal Investigator.
Okay, yeah.
That basically means the boss. So because it's a joint mission, you have a European PI and a Chinese PI, and the European PI is actually my supervisor, Graziella Branduardi Raymond. So I see her all the time, but I told her about this, and she was very excited that people are going to find out about her mission.
We'll have to get Grazia on then.
Yeah, please, yeah. I should love that.
That would be excellent. Yes, because raising the profile of these kind of missions is really important as well, isn't it?
Yeah, I think that's also what's cool about SMILE, because we've never seen the Earth's what we call the magnetopole. So this is the boundary between the solar wind and the Earth's magnetosphere. And SMILE will be the first mission that can take pictures of that magnetopoles. So it will make something that's currently invisible to us visible. And I think the first pictures of the magnetopoles, that will be very exciting to see.
I'm excited, and it's making me smile. Perhaps put a good word into Grazia and we'll get her on here maybe a little bit closer to the launch date.
Yeah, of course. Yeah.
Oh, so how are you coping then? I mean, we're practically out of lockdown now, aren't we? Are you back business as usual and heading on into university and what have you, or?
No, I'm still in Southampton. Last time I heard the lab won't be open until January. Which, I mean, yeah, it's a bit, but at least I can still continue my work where I am.
Oh, lovely, lovely. Have you made any more models? Because you had a model of Jupiter that I thought was really good actually last time. Where is that? Have you got that to
have? I can't remember where I put it. It's somewhere. No, I haven't been making any more models.
Next time we see you, I want a video, a model of the magnetopause.
Sure. Okay. I'll see what I can do.
Somehow project how that's going to look and try to make it out of papier-mâché. I'd be well interested in that.
All right.
It's been an absolute pleasure to have you on, Ophelia, and good luck with your studies and everything else that you are working on. Brilliant.
Thank you. Thanks.
Okay. Bye.
Bye.
Bye. Yes, she made it on in the end. The connection problems were happening at the beginning, but I'm really glad because every time Ophelia comes on, she just enlightens her with her enlightens us with her lovely smile. So, what's happening in the chat room? Kath, we love you, Kath. Kath, no, you've been through a bit of a tough time lately. It's lovely to see you back in the chat room. Hi, Alice, lovely to see you on the show. We hope you're well. This is a great aspect of the SPA, is making new friends. As you can see here, Kath and Alice, me and Kath, all friends because of the SPA. So apparently this guy, well, I was told that, I just didn't really know it very well, is... what's he called? Rocket from Guardians of the Galaxy films. I thought he was Rocky Raccoon, but it's not. So there we go. Go on, Rocky. You look after the couch over there. So this is the SPA magazine. This month it's about big telescopes, one of my absolute favorite subjects. The minute I saw that cover, I was hooked and knew that I had to have it in my life. So this comes out every 2 months and we are currently looking for an editor. Let's have a look here. Get a foot up into Astro Publishing. Editor wanted. There's something in here. What is it? Oh, yeah, you can make your own Hertzsprung-Russell diagram. That's really good. I can feel there's something. Oh, it's a card. Take the card out. It's a birthday card. So currently Robin's schedule is the standby editor for this. This editing job is voluntary, but it is a fantastic step up into the world of Astro Publishing. So if you are looking to elevate your career with a wonderful voluntary position, please apply within, because this is one of the best magazines of all. You get to contribute to it. You can get all your photos, observations, diagrams published in it. And it's just a great feel-good magazine. You can get your name up in paper by contributing to it and also by editing it. So please do apply. So... what time is it? 8:30. We have got one more guest to come on. We have got Tom Stallard coming on. Are you ready, Tom? We're going to come across to you. Now, last time we both had flaky internet. Hopefully this time we've both got amazing internet. 3, 2, 1.
Hello.
Oh, Tom, we're not flaky tonight. How are you?
Crystal clear. I'm good, thank you.
Crystal clear. This is what I like. You see, I have moved-ish. I'm in the process of moving to... Whereabouts are you, actually?
I'm in Leicester today.
Is that near Cardiff?
It's not near Cardiff.
If it's, I've come down to Cardiff on a whim because of a business opportunity, and it's looking like I'm going to be staying here. It's a fantastic city. Have you ever been?
I've never been to Cardiff, no. But I've heard great things, yeah. Reminds
me a little bit of Valencia, actually. Waterfront, great architecture, lots of buzz going on, sunshine. So how have you, Tom? How have you been keeping?
I'm good, yeah. I mean, as with everyone, it's been a long summer, but we are getting there. I think preparations for the coming term are really hotting up now, so hopefully we'll be ready for our students when they arrive.
And what are you gonna? Yeah, you better have your lesson plan sorted out after all this time. What are you gonna be teaching them?
Well, I do a whole range of different things for the department. I teach a bit of foundation year, which is kind of like the A levels. I teach the first year mechanics course. I teach a second year course on the planets. So we sort of talk about what the planets look like and why they look like that. And I also teach in the School of Biological Sciences, which is kind of interesting. There's a course on astrobiology, astrochemistry, and astrophysics that I co-convene. So yeah.
Fantastic. I'm just looking at the time. We're slightly ahead of time. So Robin, are you there? Robin, you might have nipped out to make a cup of tea. After Tom's finished, we'll grab Robin for the last 5 or 10 minutes and he can give us a tour around the increasingly autumnal skies. Have you had the heating on yet, Tom? It's getting cool.
Not yet, no, but it is much colder today, isn't it?
Rubbish. So today we are going to talk about a moon. I didn't know much about Enceladus, to be honest, and I know even less about Triton. Tell us a little bit more about Triton, the moon of Neptune, the main moon of Neptune.
So, I mean, that's one that I didn't know an awful lot about until quite recently, because it is very far away. It's all the way out at Neptune, but it turns out it is a fantastic little moon, very different from most moons. Maybe not even really a moon. Depends on how you define a moon, I guess. If you define a moon as being something that orbits a planet, it's obviously a moon, but there's really good evidence that it didn't form around Neptune, that it was captured. So actually, it's probably more like Pluto in its origin story, but it happened to get too close to a larger planet and got captured in that way, and that means that now it sits as a real anomaly in our solar system.
Pluto is known for its incredibly jagged geological surface. Do they think Triton's like that?
Well, Triton has we've seen Triton in any kind of detail at all once, and that's from the Voyager mission as it flew past, and it took amazing images. It has some surfaces that do look quite a lot like Pluto, but there's also some really weird cantaloupe surfaces that kind of look like a melon and are really indicative of some kinds of weird surface processes. And there's also plumes. There's active volcanic plumes. It's actually one of the very first places we detected volcanism outside of our own planet. And there's a huge discussion now about what drives that volcanism. At the time, you saw all these plumes occurring at the solar point, so directly where the sun shines on the surface. So it was thought that maybe the sun was heating up underlying regions and causing outgassing. So the geysers of material driven solely by heating from the sun. But since then, there's been different models that have suggested that it may be more like ordinary kind of volcanism, similar to what you see at Enceladus. And so there's a big discussion about that. Until we get more data, there's no way of resolving that discussion. So
now you've mentioned, is there a mission to Triton?
So there's a planned mission that I'm working with other people on. There's been a recent call by NASA for a new Discovery mission. That call went out a few years ago, and the way that missions work is you start with a broad call and you have a lot of different missions proposed, and then they downscale. So we're at the stage now with that mission. It's a mission called Trident, that there are 4 possible missions that NASA are looking into. We're at the stage of writing new proposals to fill out the scientific arguments for all 4 of those missions. And one of those missions is a flyby mission all the way to Triton. So it flies right past Triton, very close, in the hope of being able to detect the ocean underneath the surface of Triton, measure the plumes, measure the activity, and understand what the ionosphere and the surrounding space environment is like, in a way that we've just never been able to do before. Basically to resolve all of these questions about what is it and why is it the way that it is.
So, sorry, I'm just reading one Paul Sutherland's comment about Buzz Aldrin look very comfortable in the warm embrace of Rocket Raccoon. That's why I'm laughing. Sorry, I'm not laughing about the mission, Trident. Would Trident go via Neptune and have a little look at Neptune as well, or is it a Triton mission?
Well, it obviously goes very close to Neptune. It goes within about 300,000 kilometers. I'm actually involved in looking into what kind of science we could do to look at Neptune specifically, and there's some really interesting stuff. There's not as much as we would like as someone who studies the gas giants. There's all sorts of different scientific questions it won't be able to resolve, but there's some really interesting stuff that it will as well. I'm a strong proponent of having a big orbiter mission to either Uranus or Neptune at some point in my lifetime. That would be really great. So I wouldn't say that it can resolve all the questions that we have, but there will be chances as you fly past through the system to look back at Neptune and potentially resolve out some of the big questions that we have about Neptune as well, for sure.
So Neptune's got crazy magnetic fields, has it? What's going on there?
Well, I mean, in a sense, it shares that with Uranus. Uranus and Neptune both have really magnificently strange magnetic fields.
I did not know this.
The level of oddity is quite significant, even compared to some of the strange magnetic fields around other planets. Not only is it not a dipole in the same way as, say, the Earth or a bar magnet. Earth has lots of higher terms on it, but they're very small compared to the main one. Uranus has all sorts of strange bulging octopoles and more complicated magnetic fields, but even Uranus is tame compared to Neptune. We don't have a full understanding of Neptune because we only have one flyby, and so we're really limited with how much we know in detail about the magnetic field. But the current models suggest that it might have 4 aurora. So instead of the usual polar auroras, because you have 2 poles, you have a north pole and a south pole. Neptune seems to have maybe up to 4 magnetic poles, 2 north and 2 south, offset from each other around the planet at the surface. So potentially you could see aurora in different locations across the planet. It also seems to have 2 magnetic equators, which is pretty bizarre as well.
I'm just Googling. I've just had a quick Google of Neptune's magnetic fields, and it looks like my hair until I got it cut off a couple of weeks ago. It's just like everywhere. It looks like 10 spiders in the bath.
Exactly. It's a hair-raising proposition when you talk about trying to understand the aurora and understand what we might see. There's very limited images or data from an aurora from Neptune. There was a sort of detection, I guess, from the radio and from the UV that seemed to suggest an aurora, but that's literally all we have in terms of understanding what the aurora is like. So going back, getting more data would be fantastically useful. We've done observations from Earth, both with Hubble and ground-based, and we've never seen any kind of auroral signature from Neptune. So it looks like it's going to be difficult to do those observations from anywhere other than flying past. So hopefully a space mission of some kind will get to Neptune before I pop my clogs, because that would be really fundamentally interesting, I think, in a way that it will be surprising, but I don't know how it will be surprising.
So, Tom, somebody's just posted a huge long comment, and it's going to blot out our faces when I post it, but it's a bit of a cool comment. So are you ready for it?
Yes, let's do it.
Here it comes. There you go. We'll have to come. So David Graham says, you'll have to just lift your eyes up a little bit. Sat one night in August. Sat one night. We look like Tweedledee and Tweedledum or something. Humpty Dumpty astronomers sat one night in August 1995 and watched as Triton crept up to and passed in front of the 13th magnitude star TR148, a power of times 1200 on the 36. This is just showing off 36-inch refractor at the Lick Observatory. Other teams with electronic detectors on the mountain recorded a brief central flash as the tenuous atmosphere of Triton refracted the light of the star. Wow, how's that?
That's very cool. And I mean, it really highlights one of the things about Triton that makes it so interesting. It hasn't got the thickest atmosphere of any moon, because Titan obviously has an incredibly thick atmosphere, but it has this very significant atmosphere compared to a lot of the moons. So it's really interesting.
Triton has an atmosphere.
Yeah, so it's fed possibly partly by all of these volcanoes spewing material out into the surrounding space. What it does have, which is why I love it so much, is that it has probably the thickest ionosphere of any moon in the solar system. So that's the thin, tenuous atmosphere that I do my observations in. It's where the aurora sits and where you get an interaction between space and the surrounding environment. It's the footsteps of what the SMILE mission will be looking at. We were talking about the SMILE mission just a moment ago, and that's looking at the bow shock and the aurora. Those magnetic field lines come from the solar wind and down into the ionosphere of Earth. So the fact that it's got this very thick ionosphere is what makes it one of the reasons it's so very interesting.
So I've always wanted to see a mission out to the ice giants, Neptune and Uranus. Do we get a change.org petition going? Who do we petition for this?
Well, I mean, we've been petitioning it as scientists for a long time. It was in the last decadal survey at like maybe second or third highest priority, and it's likely to be high in the priority of the upcoming decadal survey as well. We're pushing as hard as we can as scientists for this mission. I think there's a lot of interest in it. We just saw a comment about how the method on the Lick telescope is how you detect exoplanets. Well, that is another reason why Neptune is so very important, because we now see, because of those detections with the Kepler spacecraft, we see thousands of planets, and many of those planets are unlike anything in our solar system, but they're most like Neptune. They're these small Neptunes or very large Earths, depending on how you look at it. So it's very likely that the kind of our view of what a planet is has changed fundamentally in the last few years, and icy worlds where there's a thick atmosphere like Neptune are actually much more common than Jupiter and Saturn, certainly. So having an understanding of the fundamentals of how those planets work has become much more important. Ice giants have always been sort of the edge of the solar system and seen as this sort of offshoot of gas giants, not very important, but now there's very many more of those worlds than there are Jupiter-sized worlds. So it's really important to get back to the outer solar system, because it's the only planets like that we have available to us to really understand what's going on in many of the star systems are in our near galaxy, where there's these wonderful, unique new worlds that we're seeing.
Oh, it's making me well up slightly. That is. Tom, thank you so much for coming on to Pop Astro Live tonight. You've done a fantastic job. I wish you the best of luck when you go back to university. Good luck teaching all those amazing astro classes, and please stay in touch and let us know how the missions are going. And if you ever need any help with the marketing or social media of any of those things, I'd love to be able to promote anything like that. That's just so exciting.
Good, great. Thank you very much for having me.
Oh, hang on one sec. Now, Alice has put a big long comment. It's not via a moon's atmosphere. Oh, okay. So she's talking about how we do a transit, I guess. Gravitational lensing. Sorry. Yeah. Excellent. And Alice also says, exoplanet and moon atmospheres are so amazing. I didn't know Triton had an atmosphere. I'm going to go away and Google that at the end of the show, Tom.
Good.
Oh, one last very important question. What's on your shirt?
The shirt is a koi pond.
Is it fish?
It's fish and
okay.
Yes, the environs of a Japanese koi pond.
There you go. There you go. Yeah, those carp are not going to want to meet a trident at any point. All right, catch you later, Tom.
Thank you.
Bye.
Bye-bye.
Bye. Great stuff there. Excellent. Keep the comments rolling in. I'm just going to do one last plug of the t-shirt. If you're wondering where my amazing t-shirt from, it is astronomy. I nearly pulled it off then. Imagine if I did that. I'll be careful, right? I'll only hold it gently. Astronomy is looking up popastro.com. It's our old vintage t-shirt. There's a picture of Heather Cooper wearing this in her obit that we did in the last magazine. And I thought, I wouldn't mind one of those. Right, okay, we are slightly ahead of time. So we are going to go over to Mr. Glowworm himself, Robin Scadgel, who has stepped in at the last minute. And hopefully we're going to learn about what is coming up in the autumn sky. Are you ready for your cameo, Robin? Hiya. Good to see you again, Robin. How are you?
Oh, fine, thank you. It's a bit late for glowworms now. We've got a few down at the lake where I recorded that video that's on the website at the moment on looking at the night sky, which I guess is why you've got me on to talk about the night sky. Is that right?
Yeah, not glowworms. Not glowworms.
Nope. A bit late for those. And except
So,
I'll tell you what happens.
Yeah.
I do get reports throughout the year of people saying, oh, we've got glowworms in our trees. And there's green, there's red ones and all that sort of. And these are laser lights, which you can now get laser decorations. We've got one ourselves, which project glowworms all over the tree. And they're fantastic. People don't believe that they are not glowworms and they've got glowworms in their trees. So if you see something like that, please don't bother to tell me about it. That's what it is.
Oh, brilliant, brilliant, Robin. So you've probably not done much astronomy lately, have you? It's been a poor summer for Astro.
Yeah, it's been very, very difficult to record those videos because as soon as I get out there, either the moon's up or the clouds come across. And the one that I did the other day, the clouds were covering half the sky, so that was a bit awkward. But I just did the bit of sky where there weren't any clouds, so it was quite a good bit of sky as well. It's a great year at the moment. Anyway, so because we've got all the planets around, we've got Jupiter and Saturn, as you can see. Even if you've just got a break in the clouds, you'll see Jupiter and Saturn really clearly over to the south, and that they're always good value. You know, there's so much to see on those two planets, and even with the small telescope, people often think that you need a super telescope to see the rings of Saturn, but you don't. You can see those with even quite a small telescope. Nothing very fancy at all, and in fact even high power binoculars will just show you that there is a bit of a something unusual about Saturn. They won't actually show the rings, but it's well worth a look. So if you've got that old telescope under the bed that you used 15 years ago and it's been sitting there ever since, dig it out and have a look at Saturn and have a look at Jupiter. And we've got Mars as well coming up. It rises about 10:30 over in the east, and you can't mistake Mars, bright red. That is really obvious, and that will be getting closer and closer.
Yeah, it just reminded me that I saw Mars last week, and it really is fiery red sequin on the sky, isn't it?
It's fantastic. It'll be at its brightest in October, and everyone will notice it then. It's really obvious, and we'll get all those messages saying, "What's that bright red thing in the sky?" And it's Mars, of course.
So do you want to go into a little bit more detail about what's visible in the upcoming months, Robin, or?
Yeah, okay, right. Well, you started me off. You wound me up like the tourist bunny. I'll carry on. So,
yeah, there's no stopping you, is there? Right, you've got to stop at 9 o'clock because that's the end of the show, all right?
All right. Okay. Now,
off you go.
Right, we've also got the planets Uranus and Neptune. Now, those are more difficult to find, and you won't spot them just by looking up in the sky. They won't be obvious, but you've got to actually what I need to do is to put a guide to finding Uranus and Neptune on the SBA website. So now that you've mentioned it, I'll get on with that, and within a few days there will be a guide to finding those two planets. Uranus is rising just a bit after Neptune, so Uranus is not rising just a bit after Mars, so that's quite a late object. But Neptune is up in the evening sky now, in between Jupiter and Mars, so it's roughly in between the two, and that will be quite easy to find if you have a fairly good telescope. And a lot of telescopes, like you've got a telescope these days, of course, which will guide you to find the planet Neptune. A question for you: have you ever seen Neptune through your telescope, Vicky?
No, I haven't actually. I saw it once from the Liverpool Observatory for a quarter of a second before the cloud rolled in, and it was as blue as your name caption on the bottom of the screen there. Just an incredibly deep, luxurious blue pixel. It was amazing.
Yeah, so if you want to catch a look at Neptune and Uranus, then do so this summer. They'll be around for the whole of the summer and autumn. I say summer, it's been pouring down today, but hopefully tomorrow will be a bit better. So take a look and have a look, if you can, at Jupiter, Saturn and Mars, even if you can't find Uranus and Neptune, which require a bit more work. Of course, we've got the moon up at the moment, so that is going to be confusing matters slightly. It will make it a bit more difficult to look at the sky. The moon at the moment, it's just getting on for the past first quarter, I think. Last time I saw it, it was at first quarter. But it is a wonderful object to study as well. So with your small telescopes or even with binoculars, take a look at the moon, and you will have a wonderful sight exploring its craters and mountains and so on. But on the video which I did, it is on the SBA website, I also mentioned some of the smaller constellations. Now, if you look up from Jupiter and Saturn, you'll see 3 stars in a line, which are the part of the constellation of Aquila, the Eagle. The brightest star is Aquila, is Altair in Aquila, and above those, almost overhead, you've got 2 other bright stars. One is Vega and one is Deneb, and those 3 stars, Altair, Vega and Deneb, form a big triangle in the sky, which we call the Summer Triangle. Now, in that triangle, you can see 2 other quite small constellations, which, despite the fact that they're not very bright, are very favorite constellations with a lot of people. One is called Delphinus, and it actually does look like a little leaping dolphin. People say that the constellations don't look much what they're supposed to be. Cassiopeia, how is that a queen sitting on the chair? It doesn't. It's a W, but not a. It doesn't form the shape of anything other than a W. But Delphinus is one of those constellations that really does look like what it's meant to be, and you can easily see the picture of the little dolphin leaping in the sky. And nearby that is another constellation called Sagitta, Sagitta meaning arrow, and the pattern of stars just forms a little arrow in the sky. So that's really obvious. And of course, if we're talking about obvious things, then there's another constellation called Triangulum, which is rising at the moment over in the east. And that, guess what? It is a triangle. And that's a very ancient constellation, named by the Babylonians and the Greeks. And the Greeks, as you know, were very fond of triangles. And so, not surprisingly, they named one of the constellations in the sky after their favorite geometrical object, the triangle. So that's up there as well. Now, I said in my video that the constellation of Lyra was the only musical instrument in the sky. And a very knowledgeable chap called Russell Eberst sent me an email pointing out that it's not the only musical instrument in the sky. There's also 2 triangles, the southern and the northern triangle, or the triangulum and the southern triangle, and even a serpent. Now, in case you don't know, a serpent is actually a musical instrument. You wouldn't blow into the sort of serpent that you normally find around the place, but this is a medieval instrument, a serpent. So it had lots of coils, and so that's why it was called a serpent. So if you want to take that attitude, then there are 4 musical instruments in the sky: Lyra, 2 triangles, and a serpent. So those are the obvious constellations which you can find, apart from the well-known Cygnus, which is the Northern Cross. That's another easily found pattern up in the northern sky, from the star which I mentioned at the more or less overhead, Deneb, not quite as bright as Vega. So if you look overhead, 2 bright stars, Vega and Deneb. And I'm doing it all for you. You don't even need to look at the video now, but you will see the Northern Cross stretching from Deneb down. That's also known as Cygnus, the swan. So there are quite a few objects which you can find very easily in the summer sky, well worth looking for. And have a look at a video, have a look at the star map, and if you must use your phone to identify them, but find them for yourself. That's the main thing. Just don't rely just on your phone.
Oh, so my friend sat next to me is just astonished at your depth of astronomical knowledge, Robin. Well done on that. Just being able to open your mouth and spew forth that wonderful knowledge is quite the skill. Very, very good. Right. Okay. So we're coming up to 9 o'clock. Any other business? We're still looking for an editor.
Yeah, I'm stuck into the November-December issue. So and the articles are coming in, and Alice has now promised me her article, which is one that we're waiting for. And we've got some really good stuff. We've got an article on Mars. We've got articles on photography. We've got articles on choosing an altazimuth mount for your telescope. If you want to get a simple mount to grab and go and take off out into the wilds, an altazimuth mount is much easier to use than a an equatorial mount. So we've got something like that about that, apart from Ian Morrison. And of course, all our usual pictures of the comets and the noctilucent clouds and Jupiter and Saturn, all in the next Popular Astronomy, which will be out in November, which I'm putting together now.
And thank you, Robin. The highlight of my showbiz career is getting a thumbnail-sized picture on the second to last page of the magazine. So thank you very much for starring me there.
You're welcome.
Thank you very much. Okay, Robin. So good night. I shall wrap up the show. So hopefully speak to you very soon. Thank you very much.
Okay, bye.
There we go. Thank you. There we go. That was it. An hour of astronomy chat. How was it for you? It was great for me. See you back here next Friday. We don't have any guests lined up. In the past, I used to pick one subject and find 3 guests about it, but we're changing it slightly now that we're going to have 3 guests talking about 3 different things. So if you would like to suggest a topic, you want to learn more about something, or you would like to come on the show yourself, please just drop us a line via the SPA social media or website and get in touch, and you can come on and chat with us. The latest issue is a fantastic mix of material, well worth subscribing for. £23 a year for this and lots of other goodies. What does this say here? Brill. Thanks, Vicky. Oh, cheers, Paul. That's really kind of you. Thank you. What has Paul written there? I won't put that comment on. So yes, the latest issue is a fantastic mix of material, well worth subscribing for. Yeah, help keep the SPA alive and vibrant. Share this video, become a member, join the fun, and tune in every Friday night to Pop Astro Live. Okay. Oh, thank you, Ian. Thank you very much. Cheers. It's been keeping me sane over lockdown doing this show. I really enjoy it so much. Catch you all later, popular astronomers. It's Friday night. Let's go out and maybe see some stars. See you later.